Alright, so the last two sections of this unit are going to be super easy. In this section, we're going to be talking about the law of sines as well as area of a triangle. So, the law of sines says that sine of A divided by A is equal to sine of B divided by B, which is equal to sine of C divided by C. Now, it's really important that you memorize this and you memorize it correctly with the capital letters and the lowercase letters. So let's talk about quickly what they mean. The capital letters indicate an angle. So I'm going to label this triangle how we would label a triangle using the law of sines. So capital A actually is talking about this angle. Let's call this one capital B, talking about this angle. And this one we'll call capital C, talking about that angle. The lowercase letter indicates the side, and the way you know where the side goes is across from its corresponding letter. So lowercase a is going to be across from capital A. So this side length is lowercase a. Capital B will be across from lowercase b, and capital C is across from lowercase c. So that's how you're going to label the triangle every single time. The C's are really hard to tell. It's the only one they're pretty much the same thing, uppercase and lowercase, so you just have to know that a side length is always the lowercase letter. So let's try an example. The way the questions are going to be presented in this section are they're just going to give you 3 pieces of information, and you'll need to find the other 3 pieces. So 6 pieces of information total, 3 angles and 3 sides. In example 1, they tell you that angle A is equal to 36 degrees, angle B is equal to 48 degrees, and that side A is 8. So we have to find angle C, side B, and side C. So I'm going to label these again. A, this one up here will be B, and this one over here is C. Oops. So then my angle A would be 36. My angle B is 48, and side length A across from capital A is 8. Now right away we should be able to find angle C because you learned in geometry that all 3 angles add up to 180. So when you subtract 36 and 48 from 180, you get 96. So angle C is going to be 96 degrees. The picture is obviously not drawn to scale. Now we need to use the law of sines to be able to find lowercase b and lowercase c. And the law of sines says, we're only going to use 2 parts of it at a time. Sine of capital A over A is equal to sine, of capital B over B. And now you have to know 3 pieces of information in order to be able to answer this. So, sine of capital A. So sine of 36 is what you would write first. Sine of 36 over lowercase a is 8. Sine of capital B is 48. Sine of 48. And then we don't know what b is, so we're just going to write lowercase b. And just like you would solve a proportion normally, you're going to cross multiply. So I call it butterfly. Cross multiply like this. And I'm going to go up here. So I'm going to have the sine of 48 times 8 equals the sine of 36 times lowercase b. And you would solve for b by dividing by sine of 36. If you do it on one side, you have to do it on the other side. So sine of 36. And if you did all of that in your calculators, you would end up getting that b is about equal to, I'm going to use the little squiggly lines, about equal to 10.11. Now, if you didn't get that for an answer when you put it in your calculator, you probably have your calculator still in radians. So you have to make sure that your calculator is in the right mode. We're working with degrees when we do sine and law of sines and law of cosines, so your calculator has to be in degrees, and you're going to have to remember to switch back and forth on the test. So, we found B. Great. Now we need to find C. We're going to do the exact same thing. So just for space, I'm just going to erase this. We're going to use sine of A and A again because that's the information that they gave us. If somehow, some way you made a mistake getting B, you wouldn't want to use that mistake to try to find your second answer. So always go back to the information that they gave you if you can. So now, instead of sine B over B, I'm going to use sine C over C. So am I getting rid of all of this stuff over here? And it'll be sine C over little c. So the sine of C, sine of 96 over little c, you would still cross multiply. So now I'm going to do sine 36 times, sine of 36 times c is equal to sine of 96 times 8. And then I want to solve for c, so I'm going to divide by sine 36. If I do it on one side, I have to do it on the other side. And I'm going to get, if I do all of that in the calculator with the mode in degrees, I'm going to get c is approximately equal to 13.5. So on a test or quiz, what you would do is you would write that angle C is equal to 96, that B is equal to 10.11, and that C is equal to 13.5. And that's how I would grade your answers. Let's try one more just to make sure. This time they're not going to give you two angles. They're only going to give you one. So we're going to have to use the inverse sign to be able to get the third angle. So angle A, I'm just going to write it in the picture so we have some space. Label it A, B, and C. Angle A is going to be 26.3 degrees. We don't know angle B and we don't know angle C, but I do know that side A is 7, so that's going to go across from angle A, and side B, across from angle B, is 6. Okay, so now I'm missing the angle. I'm still going to use the law of sines. Sine of A over little a is equal to sine of B over little b. Sine of A I know, so I can do sine of 26.3 over A is 7. I don't know capital B. I don't know the angle B, so I'm just going to write sine of capital B, and it's across from 6. Same thing, I'm going to cross multiply, writing everything exactly the same. So this time I have 6 times the sine of 26.3 equals 7 times sine B. I would divide both sides by 7, and you're going to get some number here. So when you do this, you'll get some decimal. I'm not going to actually get the decimal here. I'm going to leave it like that because I want my answer to be exact. But I do know that sine of B is equal to 6 times the sine of 26.3 divided by 7. Okay, so just like we did earlier this unit, we're trying to figure out an angle. Capital B is actually an angle, and the only way to figure out the angle is to use the inverse. That's what the inverse tells us. So we are going to use arcsine, remember sine minus 1, of all of that stuff, 6 sine 26.3 divided by 7, and that's going to be equal to our angle. So when you do all of this in your calculator, and again I left it like this instead of a decimal because I want my answer to be exact, and now I'll get that capital B is equal to 22.3. So that means that this angle up here is 22.3 degrees. Now you should be able to easily figure out everything else. So take a second and try to figure out angle C, which should be really easy. All three have to add to 180. And then use the law of sines to find little c. Alright, so after you do all of that work, you should get that angle C is equal to 131.4, and that side C is about 11.85. Now we're going to talk about finding the area of a triangle. So, you know that area of a triangle is area equals 1/2 base times height. So, and I'm going to talk a little bit about why these work later on, but for right now you just need to memorize these equations. They should be really easy. It's 1/2 AB sine C, 1/2 BC sine A, 1/2 AC sine B. So you use A, B, and C all one time. You're either using the angle on the other two sides of one letter and then vice versa for all the three letters. So let's do an example of finding the area of a triangle. Now this is going to be super easy. So what the questions are going to do to make it a little bit more difficult is inscribe something in a circle, oops, that should say circle, sorry, or make them in some sort of a problem where you have to figure out what the triangle actually is. Otherwise, it's just plugging in information. So this question is going to say, find the area of an octagon inscribed in a circle of radius 9 inches. Okay, so let's talk about what this means first. The area of an octagon, an 8-sided figure, and it's inscribed in a circle, so it's inside a circle, and the circle has a radius of 9 inches. So I'm going to draw a radius to the edge of my circle, and this is 9 inches, and this is 9 inches. That's the only side lengths I know. I don't know what this side length is over here. We're going to end up finding that. But right now, I do know, or I can figure out, what this angle is here. Now, if I were to draw a triangle to every single one of these points, they'd all have a radius of 9 because it's a circle. And you know that an entire rotation is 360 degrees. So if I evenly split up 360 degrees by 8 triangles, you would get that the angle, theta, is equal to 45 degrees. So I'm going to use the first equation. It doesn't really matter which side you call, or which angle you call A, B, and C, and which side you call A, B, and C in this problem. But I'm going to say that the triangle area is going to be equal to 1/2 BC sine of A. So if this is my angle A, that means this side would be lowercase a, which works out perfectly because we need B and C, which are both 9. So the area of this triangle is actually equal to 1/2 B, which is 9, times C, which is 9, times the sine of A, which is 45, so sine of 45 degrees. And I can simplify this even farther. I know this is 81, so it would be 81 over 2. We're not going to use a calculator at all for this, because you know that the sine of 45 degrees is really root 2 over 2, right? Pi over 4. Sine to the y value, root 2 over 2. So that means that this is equal to 81 root 2 over 4. That would be the area of just this one triangle. But if I'm trying to find the area of an octagon, that means there are 1, 2, 3, 4, 5, 6, 7, 8 triangles. So I would have to take this entire thing and multiply it by 8 triangles. If I multiply that by 8 triangles, I could actually simplify this first, and I would end up getting 162 root 2. That would be in simplest radical form. But if it's asking for area, I want it in square inches. So you could do that on your calculator and you would get 229 square inches. We're going to do a lot of practice problems with these in class. If you're interested in knowing why these formulas, let me go back one, why these formulas actually work, you can continue watching this video and I'll try to explain it really quickly. If you really don't care, that's totally fine. You can turn off the video here and start working on the problems. So here's why the area formulas work. If we call this A, B, and C, and I draw a straight line, pretend that's a straight line, with a right angle here, I know that the area of a triangle is really 1/2 base times height. That's the normal formula that we always use, right? Area equals 1/2 base times height. Okay, well, if this is A, and this, I'm calling this my height, this base here is my lowercase b, this side over here is my c, and this one is the A, but it's really not important for this question. This is my angle A. So, my formula, my original formula would be that area, remember this capital A really stands for area, not our angle A, area would be 1/2 the base, lowercase b, times the height, lowercase h. But we don't know what that height is. How could we find that height? Well, you just did an entire unit on trig, so you know that if I did sine of A, so if I found sine of A, it would be equal to the opposite over the hypotenuse. So it would be opposite over hypotenuse. And if I were to solve for this height up here, I would multiply both sides by c, so I would get that my height is equal to c times sine of A. So I'm going to go back to my original formula up here. Area is equal to 1/2, that's the same. The base, and in this case, this triangle, the base is lowercase b, times the height, which we just found over here. The height is actually c times sine of A. So times c sine A. And that's where those three formulas come from. Now, this is just one of them. The other three work if you use this angle and drew your altitude this way, or use this angle and you drew your altitude this way. So in any case, they're all the same, but that's how the formula is derived. You won't really need to know that, but if you were interested in where it came from, that's how.